Imagine a universe with no edge, no boundary, and no end. A universe that stretches forever in every direction. If the universe is truly infinite, then somewhere out there should be another Earth. And not just another Earth. There could even be another version of you living the exact same life you're living right now. In fact, in an infinite universe, there might be infinitely many versions of you. But this leads to a strange paradox. If the universe is infinite and filled with stars, then why don't we see infinite stars in the sky? Why is the night sky dark instead of being blindingly bright in every direction? And how can something actually be infinite in reality, not just in mathematics? Today we explore the paradox of an infinite universe.
Explore the universe, one secret at a time.
When we hear the word infinite, most of us simply imagine something extremely large, something so big that it is almost impossible to measure. But in physics and cosmology, infinite does not just mean very big. It means something far more extreme, something that literally never ends. To understand this, imagine you are traveling through space in a spaceship. You keep moving in one direction for millions of years, passing stars, galaxies, and enormous clusters of galaxies. Eventually, you might expect to reach some kind of edge, a boundary where the universe simply stops. But an infinite universe would never have such an edge. No matter how far you travel, there would always be more space ahead of you. More galaxies, more stars, more cosmic structures stretching endlessly in every direction. The universe would not just be large, it would be limitless. Now here is where things become even more interesting. When scientists talk about the universe, they often mention something called the observable universe. This is the region of space we can actually see from Earth using telescopes. Light from distant galaxies takes time to reach us. And because the universe is about 13.8 billion years old, there is a limit to how far that light could have traveled. This means the part of the universe we can observe is like a giant bubble surrounding us. Inside this bubble, we can see hundreds of billions of galaxies. But beyond that boundary, space may continue far beyond what we can ever observe. And this leads to an important realization. The observable universe is not the entire universe. It is only the small portion of the cosmos whose light has had enough time to reach us. Beyond that cosmic horizon, there could be vastly more galaxies, perhaps trillions upon trillions more. In fact, if space truly continues forever, then the universe outside our observable region could be infinitely larger than the part we can see. Modern observations of the universe suggest that space appears very flat on large scales, and according to many cosmological models, a flat universe strongly hints that space may actually extend forever. But if the universe truly is infinite, something strange begins to happen. In an infinite space filled with matter and galaxies, patterns of atoms would eventually start to repeat. Given enough distance, the same arrangements of particles could appear again, and again, and again. And that idea leads to one of the most mind-bending possibilities in cosmology. Because in an infinite universe, repetition may not just be possible, it may be inevitable. And once we start thinking about repeating patterns of matter across infinite space, an even more astonishing possibility begins to emerge, one that suggests there could be entire worlds identical to our own. The idea of repeating worlds might sound unbelievable, but before we go that far, we need to understand an important limitation in cosmology. We cannot see the entire universe. No matter how powerful our telescopes become, there will always be a boundary to what we can observe. This boundary exists because of one simple fact about the universe. Light takes time to travel. When we look into space, we are actually looking into the past. The light from the moon takes about 1 second to reach Earth. Light from the sun takes around 8 minutes. But when we observe distant galaxies, the light we see may have been traveling for millions or even billions of years before finally reaching our telescopes. In other words, the deeper we look into space, the further back in time we are seeing. Scientists estimate that the universe began about 13.8 billion years ago with the Big Bang. Because of this, there is a maximum distance that light could have traveled since the beginning of the universe. Any region of space farther away than that simply hasn't had enough time for its light to reach us yet. This creates a kind of cosmic boundary, known as the cosmic horizon. Everything inside this horizon is part of what we call the observable universe, the region of space whose light has had enough time to reach Earth. Inside this enormous sphere, astronomers estimate there are hundreds of billions of galaxies, each containing billions or even trillions of stars. And yet, Even this unimaginably vast region may only be a tiny fraction of the entire universe. Beyond the observable universe, space does not suddenly stop. There is no wall, no edge, and no barrier marking the end of reality. Instead, there may simply be more space, more galaxies, and more cosmic structures stretching far beyond what we will ever be able to see. In fact, the observable universe is best imagined as a small window into a much larger cosmos. This limitation creates a fascinating situation. Even if the universe were infinite, we would still only be able to observe a small portion of it, a tiny cosmic neighborhood surrounded by an unknown and possibly endless expanse. And if that expanse truly goes on forever, then something remarkable begins to follow from the laws of probability. Because in an infinite universe, the number of galaxies would also be infinite, the number of stars would be infinite, and eventually the number of planets would be infinite as well. And if there are infinitely many planets scattered across endless space, then the possibility of worlds similar to ours begins to grow in a very surprising way. Because somewhere in that vast cosmic ocean, there could be planets that look almost exactly like Earth. Once we begin thinking about an infinite universe filled with galaxies, stars, and planets, a very surprising idea starts to emerge from the laws of physics and probability. Everything in the universe is made from atoms. These atoms combine in different ways to form molecules, planets, stars, and even living organisms. But the number of possible ways atoms can arrange themselves in a region the size of Earth is actually finite, even though that number is unimaginably huge. Now imagine placing those possible arrangements into an infinite universe. If space truly stretches forever and galaxies continue appearing endlessly across the cosmos, then the same combinations of atoms would eventually begin to repeat. It might take enormous distances far beyond anything we can currently observe. But in an infinite universe, repetition is not just possible. It becomes almost unavoidable. This leads to a remarkable possibility. Somewhere out there, beyond the limits of our observable universe, there could exist a planet that is almost identical to Earth, a world with the same continents, the same oceans, and perhaps even the same history unfolding in nearly the same way. But the implications go even deeper than that. If the universe is truly infinite, then there might not be just one Earth-like planet. There could be infinitely many Earths, scattered throughout the endless cosmic landscape. Some might be slightly different, perhaps a world where history took a different path, or where life evolved in a different way. Others, however, could be perfectly identical. A planet where the same events happened, the same civilizations developed, and the same people exist. Somewhere unimaginably far away, there might even be another version of our planet orbiting another star, with another version of humanity looking up at its own night sky. And if entire planets can repeat across infinite space, then something even more astonishing begins to follow from this idea. Because planets are made of atoms, and so are we. And if the patterns of atoms that create worlds can repeat, then the patterns that create people might repeat as well. If entire planets can repeat across an infinite universe, then the same logic begins to apply to something much more personal: us. Every human being is made from atoms arranged in an incredibly complex pattern. Your body, your brain, and even your thoughts are the result of trillions of atoms interacting in very specific ways. The number of possible ways these atoms can arrange themselves is unimaginably large, but it is still finite. Now place those possible arrangements inside an infinite universe. If space truly goes on forever, and if matter is spread throughout that space in galaxies and planets, then those atomic patterns will eventually start repeating. Somewhere across the vast cosmic distance, the same exact arrangement of atoms that makes you could appear again. That means there could be another person, somewhere in the universe, who is identical to you. Not just someone who looks similar, but someone with the same memories, the same personality, and the same experiences. A person who grew up in the same environment, made the same choices, and is living the same moment you are living right now. But in an infinite universe, it doesn't stop at just one copy. There could be infinitely many versions of you scattered across the cosmos. Some of them might be living the exact same life. Others might be slightly different. Perhaps a version of you who chose a different career, lived in a different country, or made different decisions at key moments in life. In some distant galaxy, there might even be a version of you who never watched this video, and another version who is watching it at the exact same time. This idea pushes our intuition to its limits. It challenges the way we think about identity, individuality, and uniqueness. If the universe is truly infinite, then the concept of being completely unique may not exist at all. But this strange implication of infinity is not the only paradox scientists have faced when thinking about an infinite universe. Long before modern cosmology began exploring ideas about repeating worlds and duplicate civilizations, astronomers noticed something much simpler, yet deeply puzzling. They looked up at the night sky, and they asked a question that would become one of the most famous paradoxes in the history of astronomy. Before we dive even deeper into the mysteries of an infinite universe, there's a paradox that has puzzled scientists for centuries: Olber's paradox. Think about it for a moment. If the universe is infinite and filled with stars, then in every direction we look, our line of sight should eventually end on the surface of a star. The night sky should be blindingly bright, because there would be an infinite number of stars. Every inch of space should be glowing with light. Yet when we look up, the night sky is mostly dark. Stars appear as tiny points of light scattered across the darkness. Why isn't the sky as bright as the sun in every direction? This question bothered astronomers for hundreds of years. The logic seems simple. An infinite universe with infinite stars should produce infinite light. But reality clearly doesn't match that expectation. Olber's paradox highlights a fundamental tension between infinity and observation. The universe may be incredibly vast, perhaps infinite, yet our experience of it is limited. The dark night sky reminds us that something in our assumptions must be missing. Either the universe isn't as simple as infinite and static, or there are other factors at play. And there are. The solution lies in understanding that the universe is not static. Space itself is expanding, and the universe has a finite age. Light from the most distant stars hasn't had time to reach us yet, and as the universe expands, that light gets stretched and redshifted, making distant stars invisible to our eyes. This realization connects Olber's paradox directly to the larger story of an infinite universe. The universe may stretch on forever, but what we observe, what we can actually see, is only a tiny fraction of the cosmic whole. And this limitation sets the stage for a deeper exploration: how infinity interacts with the finite age and expansion of the universe. Next, we'll see how the expanding universe solves part of this paradox, and yet opens the door to even stranger questions about infinity itself. Now that we've seen how Olber's paradox challenges the idea of an infinite universe, it's time to understand one of the most important concepts in modern cosmology: the expansion of the universe. The universe has not existed forever in a static state. It began approximately 13.8 billion years ago with the Big Bang, a moment when all matter, energy, space, and time suddenly emerged. Since then, space itself has been stretching. Galaxies aren't just moving through space. Space itself is expanding, carrying galaxies along with it. This expansion has a profound effect on the light traveling across the cosmos. Light from very distant galaxies is stretched as the space between us and those galaxies grows. This stretching shifts the light toward the red end of the spectrum, a phenomenon called redshift. For extremely distant galaxies, the light becomes so stretched that it is no longer visible to our eyes. This is one reason the night sky is dark. Many stars and galaxies are so far away that their light will never reach us, even if the universe is infinite. Expansion also means that the universe we can observe is limited. The farther away something is, the faster it appears to recede due to the stretching of space. At some point, distant galaxies move away faster than light can travel toward us, making them effectively invisible forever. In a sense, the universe is infinite, but our view of it is bounded by the speed of light and the expansion of space. This creates a fascinating tension. Infinity exists in theory, yet our experience of it is constrained. And here's where it gets even more mind-bending. If space keeps stretching forever, then the infinite universe isn't just a static backdrop. It is dynamic, constantly changing the distances between everything in it. This leads to a key question. If space stretches endlessly and light can never reach us from beyond a certain point, how do we even conceptualize an infinite universe? The answer lies in understanding the relationship between infinite space and the finite age of the universe. By now, we've explored how the universe could stretch on infinitely, and how the expansion of space limits what we can see. Now let's dive into a subtle but crucial point: The universe can be spatially infinite, yet still have a finite age. The universe began with the Big Bang, roughly 13.8 billion years ago. This means that no light can have traveled farther than 13.8 billion light years, not accounting for the expansion of space. Even if the universe extends forever, we are limited to observing a finite bubble around us, known as the observable universe. Think of it like standing in a giant foggy plain that stretches endlessly in all directions. You can see a few miles around you, but beyond that the fog blocks your view. The universe beyond our observational fog may be infinite, yet for us it is effectively hidden. This creates a fascinating consequence. Infinite space exists alongside a finite observational limit. Even though the universe may contain infinitely many stars, galaxies, and possibly Earth-like planets, we can only ever see a tiny fraction of them. This limitation leads to one of the most mind-bending implications of infinity. Patterns and repetitions become inevitable. If the universe truly continues forever, the finite combinations of atoms and molecules must eventually repeat somewhere, sometime, which brings us closer to an astonishing idea. In an infinite universe, not only could entire planets repeat, but identical copies of you could exist. And that is exactly what we'll explore next, the infinite versions of ourselves scattered across the cosmos. Now that we understand infinite space and the finite age of the universe, there's another puzzle that arises when we try to make sense of probabilities in an infinite cosmos, a challenge physicists call the measure problem. In a finite universe, calculating probabilities is straightforward. For example, if there are 100 planets and 10 of them have life, we can say there's a 10% chance a randomly chosen planet will host life. But in an infinite universe, there are infinitely many planets, and infinitely many with life. Suddenly, numbers lose their usual meaning. If there are infinite Earth-like planets and infinite stars, how do we compare quantities? How do we say one event is more likely than another? This problem becomes even stranger when applied to identical versions of ourselves. If there are infinitely many you scattered across the cosmos, how do we even define your uniqueness? Or the probability of being a specific version of you? Physicists have struggled with this for decades. Infinity breaks our normal intuition about counting, probability, and even identity. Some cosmologists suggest that we might never fully resolve this problem because infinity cannot be handled using ordinary mathematics. Yet the measure problem hints at something profound. In an infinite universe, reality itself becomes stranger than anything we could imagine. Events, people, planets, and entire civilizations might repeat endlessly, yet our experience is confined to a tiny slice of this cosmic infinity. This opens the door to one of the most mind-bending concepts in modern cosmology, the idea of the multiverse, multiple realities existing alongside our own. As we grapple with infinite space and the measure problem, a new and even stranger idea emerges, the multiverse. If the universe is infinite, or if there are regions beyond our observable horizon, then some theories suggest that there may exist entirely separate bubble universes. Each bubble could have its own laws of physics, different constants, and completely distinct histories. In other words, there could be multiple realities existing alongside our own, some very similar to our universe, others wildly different. In this framework, our observable universe is just one bubble in a cosmic sea of universes. Some bubbles might contain planets like Earth, others might be entirely lifeless, and some could even resemble science fiction worlds beyond imagination. Quantum mechanics also adds to this picture. At the tiniest scales, particles behave probabilistically, existing in many possible states simultaneously. Some interpretations of quantum theory suggest that every possible outcome creates a branching reality, giving rise to infinitely many parallel versions of events, planets, and even people. So in an infinite cosmos, not only might there be infinitely many Earths and versions of ourselves, but there could also be universes where completely different versions of reality are unfolding. This takes the idea of infinity to a level that is almost impossible to imagine, a cosmos where anything that can happen does happen somewhere. And yet, even with all these possibilities, we are left with one of the most profound and unresolved questions. Does infinity truly exist in reality, or is it just a mathematical concept? After exploring infinite space, repeating worlds, infinite versions of ourselves, and the possibility of a multiverse, we arrive at the most profound question. Is the universe truly infinite, or just unimaginably large? Current observations suggest that the universe is very close to spatially flat, which hints it could be infinite. But no telescope, no matter how powerful, can confirm infinity. We can only measure what lies within our observable universe, the region from which light has had time to reach us since the Big Bang. Even if the universe is infinite, we might never experience more than a tiny fraction of it. We cannot directly observe the infinite repetitions, the countless parallel worlds, or the other versions of ourselves. Infinity exists largely as a mathematical possibility, a framework that helps scientists understand the cosmos, but one that challenges our intuition and perception of reality. Some physicists argue that infinity may not exist in physical reality at all. The universe might be finite but extremely large, giving the illusion of infinity. Others believe that true infinity could exist, but our human minds are simply not equipped to fully grasp it. What this exploration teaches us is profound. Whether the universe is infinite or finite, it reminds us of how small and fragile our cosmic window truly is. Infinity challenges our understanding of space, time, life, and even ourselves. And as we continue to explore the cosmos, we must confront the possibility that some mysteries, and like the true nature of infinity, may never be fully resolved. Infinity, after all, is not just a number. It is a concept that stretches beyond human comprehension, a paradox that makes the universe endlessly fascinating.